Some go run.
No way.
We're not like Kelton.
Yeah, no way. Too much work in running.
What up?
Fatty acids, so that's what you're breaking down right now. As you're just chilling, you're breaking down protein into fatty acids. Then we bump over into when you start working, if you start doing some type of exercise or movement right now, then we're going to break into that creatine phosphate. So creatine helps make ATP, and it's stored inside that muscle cell. So it's there ready to give you energy, but it only lasts about 20 seconds. So it's not very long. Then we run out of that. So if you use it up and you're still exercising like running, which takes a long time, then after 10 minutes we finally convert over, or our heart rate and our respiratory rate catches up to what we're doing. So we start breathing faster to take in more oxygen and spit out more CO2. I need to back up to that too. We start breathing faster, the heart starts pumping faster to move all that around quicker. So to move oxygen around, dump it off to the muscles, pick up CO2, and spit it out. So then we finally catch up with what we're doing. And so our oxygen levels come up, CO2 levels go down, and then we'll convert over to using glucose. Now we do have some glucose stored in the muscle, glycogen stored in the muscle, but it doesn't last very long either. We'll use it up. But it's there, so we can do quick movements. Again, if we were needing to run away from a bear and you got to run, you know, a quarter of a mile, I guarantee you every single one of you will be able to run a quarter of a mile from a bear. No matter what cardiovascular healthiness you're in, you'll be able to run because you've got these things in there ready for something like that. So glycogen stores glucose in the muscles, so we'll have some glucose ready. We have some, I talked about oxygen. So in the blood, inside those red blood cells, what is it that carries oxygen? There's a molecule that carries 4 oxygens on it.
Oh, hemoglobin.
Hemoglobin. So we've got hemoglobin inside the red blood cells. Red blood cells are flowing everywhere through the blood, bringing that oxygen to us, and then picking up carbon dioxide. Inside the muscle cell, we have myoglobin stored and ready for quick movements. Myoglobin is just like hemoglobin. It's bound to oxygen. It's just in muscle. So that's why we call it myoglobin, so you know where it's at. When it's not in the muscle, it's hemoglobin. Because it's in blood. Heme means blood, hemoglobin. Myoglobin's in the muscle. Oxygen in the muscle stored, ready to go. What I wanted to hit on that I didn't is the waste products of ATP production, especially from glucose. So when we're producing ATP, we give out some byproducts, and those byproducts are CO2, carbon dioxide that we're spitting out as we're blowing it off, carbon dioxide, water, and what else? What else? What happens to you when you start exercising?
Sweat.
Yeah, you get really hot, don't you?
Sweat.
So we also, ATP takes a lot of energy. The muscle contractions are taking a lot of energy. Another waste product is heat, or byproduct is heat, which is good. We want heat. So if I'm exercising, I'm running, trying to keep up with Kelton, what happens to my respiratory rate? It goes up. Why does it go up? I need more oxygen, and I need to get rid of what?
CO2.
Carbon dioxide. So your respiratory system will increase rate. Cardiac, why does my heart increase?
Because you're going to have blood to give oxygen to your muscles.
Yeah, we need to move all that around. So we need to move the blood around to dump off oxygen, pick up CO2. So it needs to move faster. Another thing that happens in your muscles, which is kind of cool when you're talking about vessel network, is normally your muscles resting, the vessels that go through it just look like that. Got one big vessel going through it, supplying the muscle, no big deal. But then when we start exercising, then you have all these other vessels, because they have little smooth muscles on them, they open up and flood that muscle. That's why it's extremely important to do physical activity and move, especially for your patients that don't get up and move. For wound healing, it increases blood flow. When we get up and move, that increases blood flow. So that's why that's very, very important. That's why they say you need to move for circulation. It increases circulation. That's why you get really red and hot, because we've got more blood running through there. So vessels will dilate in muscle to bring more blood inside that muscle. Vessels also dilate towards the skin, make us really red. Why is that? Yeah, because it's taking that byproduct of the cellular respiration, taking that byproduct to the surface and letting it out.
Why is it that when like you get really nervous or embarrassed, like you get really sweaty palms?
Because what's happening is you're stimulating your sympathetic nervous system. When you exercise, you're stimulating your sympathetic nervous system. So remember, that's that one that makes us hyper, you know, our eyes dilate, our heart gets faster, our breathing gets faster. Sympathetic nervous system is that fight or flight. We're either going to fight or we're going to run. But exercising does the same thing. It stimulates that system. Okay, so vessels dilate, we release heat. Yes, we sweat, and that's why, like I've told you before, in Florida, you know, it's very humid, lots of water in the air, it's not dry. That's why it's so hot here as well. But Florida is like 2 times worse. When there's a lot of water in the air, then we don't evaporate, so that's why you stay hotter. That's why we're at high risk for dehydration and things here, because we'll sweat, but it's not ever removing heat. Where dry climates, like Colorado, their heat, you sweat and it evaporates, so it seems cooler when it's not. So dry air is cooler for us. Oh. Anaerobic respiration is without what? Anaerobic means absent, no oxygen. So yes, no oxygen. That's creatine phosphate. When we're doing that, when we're having anaerobic respiration, we have another waste product. What is that crap that we don't like when we're doing, like Jason was talking about doing push-ups, why his arms are sore? What's that waste product that we are producing when we're doing anaerobic respiration? Yes, lactic acid. Lactic acid builds up in the muscle because we don't have oxygen, and it makes the muscle sore. So what can you do for that? To decrease soreness, yeah, you do. Yeah, you do. You work it out. So you contract those muscles, you know, later on that day, the next day, stretching, any of that will help contract those muscles, increase blood flow, because remember this happens, will increase blood flow to the muscles to remove that lactic acid. So we can pee it out, get rid of it. So moving them is ideal. So aerobic respiration is what then? With oxygen. So that's what we're doing here when we're starting to breathe faster and heart's up and we finally caught up. All that's on page 140 though, and I really like the diagram that they use there, telling you about it. Okay, we need to talk about lastly here. My video catches up over here. There you go. We need to talk about, we did origin and insertion when you built your baby. So origin is the most proximal and it's stationary. This one doesn't move. So it pulls on across a joint, pulls on an insertion, so it will move that part. It's the movable part. This one's stationary, this one moves. We also have what are called primary movers. So primary movers would be this bicep brachii. Bicep is the main guy flexing that bicep or flexing that arm, moving that forearm up. You also have what are called synergists. So when we're extending that arm, we have triceps, and then you may have some other smaller muscles helping to extend it. As well as when we flex, your bicep brachii is your main guy, but he may have some other, like brachioradialis or something, helping pull that arm up. They're not the main people. They're just helpers. They're working together. They're synergizing. When a group is synergizing, they're working good together. So synergists, they work together. So in like English, who is the bad guy or the one opposing your main character? An antagonist. So muscles have the same thing. They have antagonists. So when I'm flexing this arm, who is my antagonist? Who is working against my bicep brachii? Your triceps are. They're doing the opposite. So if I'm flexing bicep brachii, triceps is doing what? They're relaxing, yes. Because if this one contract, if my tricep and my bicep contract, what's your arm going to do? It's not, it can't move. You're not going to be able to do anything. So when my biceps contract, my triceps relax. When I extend my arm and my triceps are contracting, my bicep is the antagonist now, and it's relaxing. So you have an antagonist, you have a primary mover, you have synergist, all working together. At rest, muscles obtain most of their energy. What are we metabolizing again? We're eating all that beautiful muscle. We're metabolizing fatty acids. So a lot of this comes from Latin terms, and so for your muscle groups, what they're named, and especially when your muscles, they helped you out in some areas. If you think about your vastus lateralis, so one of your quadricep groups, or your so vastus lateral, it'd be on the lateral side. So they kind of helped you out a little bit with those. Adductor muscles, if you're adducting, adductor muscles are on the inside of the leg, and they're bringing that leg in, contracting to bring it in. So they do help you out with some of the terms, where they're at. And gotta know, you don't have to know all these. I'm going to go over these again when we get into respiratory system. I'll go over those muscles. Inspiration, yeah, we'll go over those with our respiratory. That's it. Tomorrow we'll do, so flexing the forearm, what was the main guy? Your bicep. Oops. Flexing forearm. No, bicep brachii is your main. Okay. We'll come, I've got some fun stuff to do.
It's over.